I mean what we started yesterday. So, what you are seeing in the Excel sheet, this is a point count which I collected from all of you. So, if you look at this number, I have about 42 counts, right, from each one of you. Anyway, I will write it on the blackboard for the clarity, but for sake of audience who is sitting here, you can just look at this. We have also collected the intersection from each one of you, and the average point count is about 5.94, and then average PP is 0.17, and the average intersection is 18.99, and then the average PL per micrometer is 0.01, and then average D in micrometer is about 79.67. Okay, before I sum up these results and then relate with this microstructure, what I will do now that how you use this micron marker to analyze this microstructure. Okay. So, the micron marker which is shown here is about 200 micron, this length. So, and then if you measure it with the scale, this is about 17 mm, and then if you also measure the grid lines, this is about 51 mm. So, let us write all those things on the blackboard. So, this is magnification marker, it is about 17 mm. The length of the grid line is about 51 mm. So, that 17 mm what we have measured with our scale is equivalent to 200 micrometer. So, we have 51 mm. So, that is approximately, you can calculate by 17 into 51 is equal to 600 micrometer. So, you have in the grids, we have about 6 lines which we have used. If you count this 1, 2, 3, 4, 5, 6. So, total length six lines is 6 into 600, which is about, so total length is 3600 micrometer. So, what we can do is, so this measurements what we have done yesterday from the whole class, I will show the data. So, this is suppose there are two ways to do it. Either you take the sum of the whole point count and then divided by the number of events you measure, or you can individually calculate PP for each event and then finally take an average. Both will give the same number, and then what I will do is, I will first if you sum up all this, you will get this the sum of point count is about 249.5. So, the average point count is, this is, we have about 42 events. So, this is divided by the 42, you will get about 5.94. So, this is average point count, and then you get the average PP. So, probably we can which is equal to, you see that 0.17, and similarly we can look at this for calculating the PL, the total number of intersections, sum of which is equal to 797.5. And then you have the average PL in micrometer. Is what we have calculated is 0.01. And then if you want to calculate the diameter, average diameter, like what we have shown in the yesterday's lecture, the formula, which is that also we have done using this, which is about 79.67. So, you can relate this number 79.67. I will also write some few expressions which will relate this diameter with the mean intercept length, and some other relation, stereological relation also I will show. But what you can learn from this number is, now you look at this image and look at this micron marker, it is about 200 micron. The average size of this, whether it falls within this range, that is what you have to just look at it visibly, and if you do it, I think it falls good, right? It is about 80 micron. So, you can also look at the mean intercept length through this data. We have PP, this is by PL. So, we have PP and PL. So, this and this, so you can calculate the mean intercept length using this, and we can also, we have seen that already, this is average D, which is related to 4 by pi times the, this is also another relation which is very powerful. We can simply calculate this. So, we can also do something called, see when we, if you remember yesterday when we measured the boundary length, right, with that intercept we measured, we can also derive some other parameter called boundary length per unit area, which is equal to pi by 2 into PL. This is also possible. So, that means the diameter that each one of this boundary length per given unit area, that is also possible from this relation. So, we can check with all those. I think later we will compare this results with probably image J, probably in the later stage, and I think we will stop this analysis at this stage, and we will continue with the next topic, and then we will use the data again. Okay. So, I will leave it to Professor Sandeep to continue, and I will come back again.